Hey everybody, Mr. Tannen here. Today is indeed our asynchronous day, so I wanted to put together a little video for you to check out here. Where'd I put my Apple Pencil? I'm gonna have to restart this video. Oh, there it is. Got it. So, hope everybody's doing okay. I know there's some anxiety around the election and everything, and just give yourself space and patience and take care of yourself. That's the main thing we can do. But maybe some math will be a nice way to engage our minds with something else, because it could be a little bit of a wait, especially here in Pennsylvania. I'm hearing the final count may not be done until Friday or later even. So find the values of x at which y equals the quantity x plus 3 divided by the quantity x plus 2 is parallel to y equals negative 1/4 x. Interesting. So I know Kai had broken down the previous one quite nicely for us, but it looks as though, once again, we're trying to find, well, this is actually a linear equation, right? With a slope of negative 1/4. And we know that the derivative gives us the slope. So if we find the values of x at which this is parallel, even if it's just parallel for a moment, that's when the derivative would equal the slope of this, which is 1/4. So I think, kind of like we had Kai's strategy last time, I think our strategy on this problem would be to set the derivative of the function equal to the slope, because parallel means having same slope, and the slope is negative 1/4. Alright, so, oh, this looks like it's going to involve that new rule we got. Low D high minus high D low. Okay, so y equals, first let's write the function first, just to have it. So let's take the derivative, dy dx. This is normally the way you'll see the derivative written if it's y and x. So because it's a small change in the y over the change in x. One is Lagrange notation and the other is Leibniz notation. I'm trying to remember which is which. You know, like we've got the f prime, which is equivalent to this. Normally this is if we're given a function, we'd write it this way. If we're given y and in terms of x, we would usually use this one, Leibniz or Lagrange. I'll have to look that up and tell you tomorrow. So the derivative, low d high minus high d low. Yes, okay, low d high minus high d low over low squared. Okay, not too bad so far. Well, the derivative here of x plus 3 is actually just going to be 1, because the derivative of the constant is nothing. Derivative of just x is going to be 1, and then it's going to be a constant because the power goes down to 0 of x. So this is actually not going to be too bad. So my derivative is going to equal x plus 2 times 1. Nice. And then the derivative, very similarly, of my denominator is also 1. And I'll just leave this as x plus 2 squared. Now, moving over here to the right, I'm just going to get x plus 2 minus x plus 3. I could distribute my negative there. So that would just be x. I know some of you are like, Mr. Tannen, why are you writing out all these steps? Well, good to be thorough. So the x's would cancel. I'll just get 2 minus negative. No, 2 minus, I already distributed negative. 2 minus 3, which is negative 1. over x plus 2 squared. And now, like we did similarly on the last problem, we want to find where is that going to be equal to negative 1/4. So we now have to solve for x. So one thing you could maybe think about is, well, if it's both negative 1 over that and negative 1 over that, well, to make these equivalent, we just want to have x plus 2 squared equals 4, which is a bit nicer. So that's going to give me x squared plus 4x plus 4 equals 4. Oops, why did I write? Getting ahead of myself because I'm thinking I know I want to get equal to 0 to solve. So now if I continue to simplify, I could subtract 4 from both sides. I'm just going to get x squared plus 4x equals 0. Oh, this is actually a quite nice one to solve, because all I have to do is factor out the x and then use my zero product property. I can see that x would be 0, or x could be negative 4, because both of those would give me 0 in this equation. So what that means is at those two values, this function, this rational function, which looks like this, is going to be at that instant parallel. And looky here, so the tangent line at x equals 0, which was one of our solutions, you can see for a moment the tangent line is parallel to our line y equals negative 1 over 4x. And here, also at our second solution, x equals negative 4, right at that value right there, the tangent there is also parallel, because the derivative at both of those points is negative 1/4. We just did it by finding the derivative, setting it equal to the value that we wanted it to be, and then solving. Wow, interesting. Using the geometric definition of the derivative to find a solution once again. So what I have posted on Google Classroom, you may have seen, is this document for the quotient rule practice. I did put a little description that there's some issues. I don't necessarily love the way they express the answers in the answer key. Well, it gives you two answers. It gives you a totally unsimplified, but then a fully simplified. And what we've sort of realized is that we leave the denominator unsimplified, but we should simplify the numerator. That's sort of how it's been working well for us. So this one's a little bit different though, because they ended up doing some canceling, but you could just leave it in this case like 40x over the quantity 4x squared plus 2x. This one you could just left it 24x cubed over, or sorry, negative 24x cubed over the 3x to the fourth minus 5, so on and so forth. But here's some good ones to practice the quotient rule. They get progressively more challenging. Just remember low, d high, minus high, d low, all over low squared. So some of them get a little bit more challenging as you go on, but not too bad, I don't think. These ones, obviously, you may want to think about rewriting for 9 and 10. They get a little funkalicious, but the answers are indeed provided on the next page. Shall I try number 7 here? Alright, so I've started to practice these quite a bit, so I know it's just going to be low, D high. Actually, what I'm going to do is, just for sake of space, I'm just going to do the derivative. Well, I know the derivative would just be 20x to the fourth, because minus high, d low, which actually has the same derivative because that first term is the same, all over low, oops, squared. And I'll just leave that low squared as is. And presumably you could do these in your notebook to get more space. I could multiply this out. I would get 80x to the ninth plus 100x to the fourth minus Well, this is just going to make both terms negative. 80x to the 9th minus 80x to the 4th. And then lastly, wow, those would cancel, okay. 100 minus 80 would just give me 20x to the 4th, and I would leave the denominator as it is written. And if I'm not mistaken, if I scroll down here, what was that, 7? I did get the same numerator, 20x to the 4th, and that would be the denominator if I went about squaring that. But like I said, we could leave our answer as it's written. Much love, everybody, and look forward to seeing you all tomorrow. Stay safe, and don't hesitate to tell me if you need anything at all. Much love.